Now, good day, good afternoon, everyone. I hope everyone is well and that everyone is having a good summer starting today. Summer is not my favorite season, but I understand other people do like it. All right, so welcome. Today we are going to work on task groups in Go. This is work that we started quite a while ago, and it is a suggestion to extend the Go runtime with logical task groups. So there is an RFC document which you can find from this issue on the CockroachDB repository. And there is some code that we started writing on livestream a while ago as well. So let's see. This is, I think, the PR where this is being prototyped. And we are looking at a branch on the fork of the Go repository in that with that name. All right. I have a little hope that the audio is working today. If you are in the chat today, can you confirm whether you can hear the microphone properly? Because last time we had issues and I want to check this. Thank you. Well, I'm not hearing. I'm going to briefly make a small technical adjustment to verify that the audio works fine. I'll be back in a sec. I think we had a little technical difficulty and now it should be fine. Thank you for waiting. So we are going to rebase our branch. And there are quite a few different changes we need to rebase. Oops. I need a authentication key. I need to grab my authentication token. I'll be back in a sec. There we go. All right, so this is built. Let's make it again. Verify this built still properly. I don't see much reason for it not to build anymore, but we'll see. All right, so this seems to build still since last time. We rebased it to the latest 1.16 branch. Eventually, we probably need to rebase this on the 1.17 branch since Go 1.17 is coming out quite soon. But let's keep it at that for now. So I'm going to write a to-do list for today. Go runtime. So we have already rebased to that has. And so what we're going to do today is to design experiments with ways for programs to utilize the runtime extension in a backward compatible way. And so we have multiple experiments we can run to achieve this. We can try to play with build tags, or we can have a client API with this linker magic, or we'll see. So goal is can build and report valid, meaningful messages compiled against a vanilla Go runtime. All right, so we rebase the branch that has been built, and we're going to check if our branch from last time still beats. You know the drill. Rebase this branch. Then get the branch from last time. Rebase that. Alright, so there is a little bit of a conflict, but that's okay. It's a generated file, so we can deal with it. And from last time, we also had a test program that was using the new API. And that was a recommendation from Jordan in the chat, which I think was a very good recommendation because it saves the build time of CockroachDB. So we should test that the CockroachDB code is fine. So what we see here is the problem we need to solve today. Right, so the PR that we are building today is so this CockroachDB PR is dependent on the runtime extensions described in this RFC. But because we are using a runtime extension, it fails to build successfully on a vanilla Go runtime, and so we get those build errors. And so it's kind of undesirable because we still want to give the ability for people outside of organization to use a standard Go runtime to build CockroachDB and only lose just that specific part of functionalities that we have in our customization of the runtime. So today's goal is to ensure that the test code that uses our extension builds both with a vanilla runtime and a custom runtime. And when used with a vanilla runtime, the API should return errors or something meaningful. So we'll see about that. We might need to adjust a little bit the implementation, and we'll need to try out different things. But let's first check that with the runtime extension, this works fine. So what I'm doing here is that I'm rebuilding the CockroachDB branch with our PR with the customized Go runtime because we want to verify that the process still initializes properly and we don't get crashes and this kind of things. All right. I think this builds fine. Hello to all the viewers today. Welcome. All right, this seems to build. We are going to complete the rebase over here. On. And that seems to have completed. All right. So it's still So this is linking. Hi, Rain, and let's see what it says. Where was it? Ooh. Where was it? In which? There is a CRDB internal thing, right? Over here. Oh. Yeah, show transactions. No. Yes, here we are. All right. So, CPU time, schematics, and large bytes. So that's these are the 3 new fields we have added in the PR, and that seems to still work fine. So we're good. We're more or less good with this. Cool. Transaction could benefit from this eventually as well. My large bytes metric doesn't seem to work anymore. Let's see what the RFC was saying about the memory monitoring. Let's see. You had a an example in the RFC to explain this one here, right? And this PR here didn't. I wanted to have some concepts here, some example. What is something that will allocate a lot of data? So generate series is not it, actually. It doesn't really generate a lot of data in one go. So we are going to do this in a different way. How do we do this? We need to generate a lot of data. So I think concat ag. There we go. Yep. Okay, so our memory allocation seems to work fine. Cool. Right. Alrighty. We are good on this PR, so that has rebase. And now we're going to push this to GitHub because we are done, so that is done. And now we are going to use our test program, which is a smaller program. Oops. Because it's actually kind of unwieldy environment to be using CockroachDB for all the testing. So how does this work? What is this test program doing again? Oh, 100 times. All right, so yeah, it shows that the memory usage oscillates, I think, until some maximum has been reached. Anyway, so this test program works. But if we don't use the customized Go runtime, we get a build error. So that's like the goal we want to solve, is that this program builds properly. How can we achieve this? So there is one option, which is to try with build tags. That would be really the preferred option. If that works, that will be the best option, because then we can create a add-on package, Go package, that will proxy the API from the Go runtime conditionally based on the build tag. So that would be the best way forward, if it's possible. But I don't know if it's possible, because I actually don't know how the compiler works. So today we're going to investigate the Go compiler a little bit and see if there is a way to coerce it into producing build tags. But we don't know where this is defined. So Go, let's see, tags, main. All right, we probably have no choice but to actually go and check for tags. All right, so where are the tags defined? Probably something around here, I suppose. Tags. All right, so I like this. Minus tags. So we want to have tags. Internal imports. Where would the build tags be defined? I really hope there was a file called tags or something. Let's do this. Oh, here you go. Import tags. Let's see. CMD Go internal imports tags. Tags returns a set of build tags that are true for the target platform. It includes Go as Go RC compiler, possibly C Go release tags, and user specified build tags. Maybe this is what we need. Where is this used? Oh, here, tag once. Tags. Okay, and where is this used? Import any tags. Any tags. Nearly all build tag expressions. Malform tag requirements. All right, I like that. Read local tags from the local Git cache into the interesting. Not fetch. So apparently it's possible for tags. Local tags. Okay, so that's not the same as build tags. So we're not looking at the same things here. Build tags, build tags. We're having a little attack of chat programs, chatbots. Let's moderate this away. Give me a sec. I need to click buttons. There seems to be a little deluge of spam messages. At some point, I should complain to the Twitch moderations. There is a automatic Twitch filter on chat messages. I just don't remember why. I mean, like, there is already filtering something that should prevent this kind of spam attacks, but there might be settings that I haven't customized properly. So we will investigate this eventually. All right, a little bit of a cleanup. I think this is better. All right, so build tags. Where are those defined? Build context, generate. All right, so build tags. Okay, so that's not really doing anything. Build tags. Oh, go experiment. Oh, I like this. I like this a lot. So apparently there is such a thing as adding additional tags, experiments. For each experiment that has been enabled in the toolchain, define a build tag with the same name but prefixed by go experiment, which can be used for compiling alternative files for the experiment. This allows changes for the experiment like extra struct fields in the runtime without affecting the base non-experiment code at all. I like this. Okay, so there is a system called experiments. Toolchain experiments. This has control with a go experiment environment variable recorded when the toolchain is built. Oh, I have not seen this. Oh, interesting. So there is a thing called go experiment in a constant in the source code. I like that. Set field frame pointer. Oh, nice. Interesting. All right. Okay. So this is one way to do this inside the runtime code. Then we're going to look at this too. This is also known to CMDGC, all right. I believe you. And where is Xspring being tested? Compile X will fail if the build tags that are enabled or not enabled for the frame pointer and field track are not consistent with the value of Go Xspring. Yes. Has exp entry. Is here. All right. So the Go runtime internally has tags for experiments, but they are configured by forcing the experimental tag to be set, and that's not what we're doing here, because what we're doing here is adding fields to existing runtime structs and conditionally, and that is not going to be easy to provide inside the runtime system as a conditional thing. So these experimental tags are not what we're looking for. They're a nice idea though, but what we're looking for is a unconditional build tag. And where did we have this? I think it was in internal imports tags. Here. Go enabled. Release tags. What is release tags? Clients creating a new context may customize build tags, which defaults to empty, but it is usually an error to customize release tags. which defaults a release of Go releases Go release compatible with build tags. It's not set for default build context conditions build tags. Tags. All right. Yeah, so I think tags are going to make it work. We're going to operate in two different stages. We're going to create a library for accessing these new facilities that is going to be a regular Go package, not the runtime system directly. And that is going to only deliver services if a build tag is available. And then separately, we're going to tell users either you configure the build tags explicitly or we will have the Go compiler set the build tag. All right. All right. So let's create this library. Let's see. Do I still have permission to create a repository here? Maybe I have. Oh yeah. What do we have here? We need to find a good name for our library. So what does it have? Task groups. Not only task groups, there are more features in this batch sets than just task groups. So we need to call it a new thing here. Go plus. API library for custom Go extensions. Public. Git ignore for Go. License is Apache. Commit message lint. Exhalate single. I don't know what those things are. So let's do this. And now we will need to clone this. Cool. And now we are going to define our API. Cool. This should work. Oh. Okay, we are going to create what I'm doing. We are going to create a doc later. What we're going to do is to implement our APIs here. Test.go. Set internal task group. All right. read task group. And here we are going to have a task group package. And then we are going to say yeah, I know it's possibly malformed, but it is actually not. It is actually not. Okay. Cool. I need to okay. Go.mod. And then that will come later. And we are going to check this. Read. Why did we have something that was specific to task groups here? Oh, because it's cheaper. So why? right. Sample not appearing with a value at kind bad. Its name is unknown. We probably want this API to be to document the calls, but have the implementation in a separate file instead. Let's do this. Nope. All right. On, off, okay. I don't remember how this works. Let's see how it is implemented in the Go runtime. Here. Kind bad, so let's see how this is implemented. I like that. Name value. All right. That is the off version. So the off version has interface. Off we go. This one has the on version, and now here in api.co we have this one. Sure. Access. If the extension is C matrix, value will be all right. This one doesn't have a build tag. We probably need some kind of license. Let's see. Let's do this. Like this. Like this. Alright, so the build tag comes just before the package name. Cool. Cool. That was our first API. And this has the wrong year. Let's fix this. Like this, and then we can test it. API on, redeclared. Oh, okay, so the build tag logic doesn't seem to work fine. Oh, there is no colon. That was a mistake. So it's currently seeing both declarations side by side, but I do have build tags here defined. So why does this not work? Oh, okay, so there needs to be a space, in fact. All right, that's better. Yes. Here we go. All right, this builds. All right. And then if I say tags, we get the error message. Excellent. All right. Cool. All right. All right. All right. All right. Let's continue. What is the other API we had in our task group thing? So we have this one needs to go away. Probably goes away afterwards. Yep. Set logical task group ID. How are these allocated though? I wonder. Okay, we're going to do this. Dun, dun, dun. So it's a separate concept from task groups. Oh, task group ID. Oh, here we are. We want to look into this RC to see the difference between the group ID and the task group. All right. Okay. We're going to explain the difference between the class group ID and the GoRoutine ID in a second. All right. Even that being said, it has been 1 hour of work, and to be healthy, it's important to take breaks. Every hour, we need to hydrate and move a little bit. So we're going to take a 5-minute break, maybe 5 past half the hour, maybe 7 past half the hour. We're going to convene back and continue this, and hopefully we'll have an API ready in a bit. All right. So enjoy your break, everyone. See you in a bit. We are back on stream. All right, so there is a little bit of a a duplicate concept here. How to explain this? We have two different concepts with the same name, called the internal task group struct, and then the logical task group ID. And there are really two different things. And do we like the fact that they're different? All right. I don't know whether we like it or not. That's a bummer. But we do need to call it internal here. That's actually pretty important. I don't like the fact that we have two different concepts. They are both called task groups today, but they're actually implemented separately and they serve different purposes. So that's kind of a bummer, and we need to talk about that. We have the task group context and then task group logical ID. But they're not scoped to each other. There are really two different trees of concepts, and maybe they shouldn't be called task group, really. They're like inherited attributes. I think the internal task group ID is the strongest of the two, and the other one is some kind of inherited ID. Let's do this. We're going to call them separately. So internal set task group. All right. We are going to call them separately, and we're going to have two separate packages for them. And we're going to have a separate package for the Go routine. And here we're going to have separate implementations. Same deal as the other one. Right. Here we have now a new API for Go IDs. And so we're going to do this because it's much easier, in fact, to understand. Where are the changes? we have the this API here. All these APIs is what we're looking at, actually. That's really exactly what we want. Where is this defined? Here in proc API. All right. I don't. Maybe the word go ID is not the right name. Let's rename this package for fun. Go ID proc. Come on. Proc API. Proc. 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 All right, and now we are going to open the file that defines all this. This one here, and then we're going to bring all these things inside here because we like their doc strings. Limeti008 is asking on chat, what are you working on? And the answer to this is we are working on this work here, task groups in Go and customization for the Go runtime. And because we're customizing the Go runtime, we're creating a library to access our customizations. The goal for today is to ensure that a program that uses our Go runtime extensions properly compiles without errors, whether or not the extension is present in the Go runtime. So that's what we're doing today. Limeti is asking, so extensions are basically for performance improvement and will fall back to another implementation if not supported by the runtime. In fact, that's a little bit more complicated than this. These are functionalities that cannot be implemented by an application if the runtime doesn't implement them. So the client code will probably have to do different things depending on whether the supported API returns true or false. All right, so this is something that has been called task group ID in the past, but it's not a good name. We need to rename this. See. Right. Cool. So we have plenty of test functions here. And now we are going to implement all these API functions in both the supported case and the unsupported case. All right, and now we are going to make mock implementations for the case where the API is not supported. This one we're going to look at in a second. And now we're going to do what it says. This one does nothing. This one 0. This one nothing. This one. Okay. False. All right. So why do we have something not defined here? Is because we actually can do something here, I believe. Off we go. Oh. Cool. API.go 992. What does it say? Cool. And that builds too. All right. So we have our task group API, and we have our let's document this a bit further. As to but orthogonal C inherit Cool. Cool. We probably need to have some way to say whether two things have the same task group. Probably we can compare the references. We're not... All right. Just looks like we have a library. Is there any other change in our patch that we have not yet provided as an API? Maybe this one here. I like this one. Let's do this. Yep. Cool. That works. Now, we might want to be clever about creating sections. Do we have the ability to create subsections in the Go documentation? Yeah, so it doesn't look like GoDoc has the ability to create subsections. Oh, that is sad. Oh well. All right. Let's actually document this. All right, so GitHub. And then we want to have GoDoc. Cool. Let's see if there is... Yes, we are. Is there even a way maybe to remove this to make it more generic? Yes. And then this is going to be just group. Oops. And then we're going to document this here. Programs should use a C-ported API function to determine. All right. We actually need to explain how to use this. Oh, we can call it Go Plus. Cool. I think this is what we needed, and we're going to change the serial text. Cool. How does markdown tables work? Access. Okay. Let's go. I think this is working like we want to. Cool. I think we are about done. The build tag idea actually worked. So our custom Go runtime extensions compile on 1.16.5. The QuakeWorksDB applications that use it seems to work. We can create libraries that uses tags, and we are going to test our program here. And then we are going to call this task group T. Call. Now we can test our test program. Okay, so that's actually what we wanted. Okay, so we are not, this doesn't seem to work fine, and we have a problem. API off is false. Wait, our Go plus directory seems to not have work. I think we just erased the custom. Okay, this one is fine. This one is not fine. It's using a very old commit, so you're using this commit here. It's not using the latest one. Let's try. This is not working fine. Apparently, we're not able to get a proper version here. So let's do this like this. We want this one. That's better. It's still not working, so. Oh, it is working now. All right. We're going to clarify this in the documentation. Cool. I think we have achieved. We have achieved for today. We have created this new library with interfaces to our extensions, and there will be some documentation ready over here, and there are some typos, but people will provide issues and pull requests perhaps to fix them. All right. So we achieved this, a new library for the Go runtime, and hopefully this will stand the test of time. And we will need to update the RC to explain the fact that the logical task group ID are now called inheritable Go routine IDs. Let's And everything that comes after this will be a little bit of polish and probably some example programs. All right. So thank you for accompanying the creation of this new participants in the Go ecosystem, and hopefully we'll get a lot of feedback and improvements from this. So thank you for being there. Thank you for accompanying the stream, and we will see each other again next week. Have a great week, everyone. Goodbye.